Hi, in this video we're going to talk about the frequency tables, what kind of tables they are, why we need them, when do we need them, and how to construct them. So once we've collected the data into some tables, we need to be able to make the analysis over them. And usually the tables may contain the 1,000 or a million data points, and it's really difficult for us to see some important points and insights about the tables. And we need to learn how to write them in a more compact form. And the frequency tables, it appears, can help us to write them in a more compact form. So let's consider an example of how to construct the frequency tables and what are the frequency tables. So I've got the 40 measurements of the pulse rates. So here, this table contains the measurements of the pulse rates of the 40 males. Here, for example, 68 or 64, 88, 72, 64 are the measurements of the pulse rates. So I've got another table with the measurements of the pulse rate of the 40 females as well. So here, 76, 72, 88, 60, 72, and so on are the pulse rate measurements of the 40 females. And just looking to this 80 cells of the data points, it's really difficult for us to see the distribution of the points or to see some insights about the data points. And so the idea is to write all of this huge tables in a more compact form. So the idea is like this. I've got a table with 40 measurements of the pulse rates. What I would like to do is I would like to count, hey, how many pulse rates are belonging to the different intervals. For example, I would like to create the intervals from 60 to the 70, from 70 to the 80, from 80 to the 90, and so on. Then I would like to count, hey, how many pulse rates are belonging to the first interval, to the second interval, and so on. So let's start from the first interval. So I've got an interval between 60 and 70, and now I would like to count, hey, how many of the pulse rates are belonging to this interval between 60 and 80. I would like to count this. It's going to be 1, 2, 3, 4 in the first row, 4 in the second row, 1 in the third row, and 2 on the third row. It's going to be 11 pulse rates, or 11 females had a pulse rate between 60 and 70. And I'm going to do this for the other intervals as well. So I've got this table, and this table I can make some analysis. I can see that, hey, most of the females have the pulse rate between 60 and 80, for example. So we are going to learn how to create this kind of tables. And before we do this, we need to first of all talk about the properties and characteristics of this kind of tables. So there are 5 different properties, or the like attributes of the tables. So the first one is called the lower class limits, are the smallest numbers in the class limits. So here, for example, I've got 1, 2, 3, 4, 5, 6, 7 classes, and for every class I've got the lower class limits, like they are the smallest numbers which can be included to that class. It's like 60 for the first class, 70 for the second class, 80 for the third class, 90 for the third class, fourth class, and so on. So the upper class limits analogously are going to be the maximum numbers which can be included to that particular class. So for the first class it's going to be 69, for the second one it's going to be 79, for the third one it's going to be 89, for the fourth one is 99, and so on. So the class boundaries are the numbers which separate the 2 classes. So here, if I look to the first class and to the second class, it's really, so there's no basically a number between those classes. So that's why what I would like to do is, so here I say that the class boundary between the first one and the second one is going to be 69.5. So the class boundary between the second one and the third one is going to be 79.5, and so on. So I would like to define the class midpoints as well. So it's a point which is in the middle between each class. So in order to do this, we need to add the lower class limit to the upper class limit and divide them to the 2. For example, for the first one, it's going to be 60 plus 69 over 2. 60 plus 69 over 2 is going to give us 64.5. For the second class, analogously, it's going to be 70 plus 79 over 2. It's going to be 74.5. They are the class midpoints. And one of the most important attributes of the frequency tables is the class width. So this is one of the important attributes which helps us to create the frequency tables. So the class width is the difference between the 2 consecutive lower class limits. So for example, here, the class limit is not the difference between the upper class limit and the lower class limit. In this case, the class width is going to be the difference between the two consecutive lower class limits. For example, I've got the two classes. For them, the two lower class limits are 60 and 70. Their difference is 10. And in this case, the class width is going to be 10. So this 10 is, so the class width is the same for the difference between the any two other consecutive lower class limits. For example, if I choose the second class and the third class, so the difference between the two lower class limits is again 10. So let's do a couple of exercises in order to try to understand those attributes of the frequency tables. For example, I've got this table and I would like to calculate the class widths, class midpoints, and class boundaries for this table. So in order to find the class widths, I need to take any two classes, any two consecutive classes. I need to choose their lower class boundaries, and I need to find their difference. So in this case, the difference is equal to the 4, right? So the class width is equal to the 4. So in order to find the class midpoints, we need to add the lower class limit to the upper class limit and divide them to the 2. So for the first class, it's going to be 10 plus 13 divided to the 2. It's going to be 11.5. For the second class, it's going to be 15.5. For the third class is 19.5. And for the last class, it's going to be 23.5. So please note that the class midpoints are also a really important concept because we're going to use them in order to calculation of the average values of the frequency tables later on in our next lectures. So let's find the class boundaries. The class boundaries are going to be the numbers which are between the two classes. For example, the class boundary here is going to be equal to the 13.5. The class boundary here is going to be 17.5. The class boundary here is going to be 21.5. So let's do one more exercise. So I've got another frequency table. I would like to calculate the class widths, class midpoints, and the class boundaries for this table. And again, so I can choose any two classes. For them, I can choose the lower class limits. So the difference between the two consecutive lower class limits is equal to the 1. So that is why the class limit is equal to the 1 in this case. So we can choose any two other classes as well. So for example, the difference between the 3 and 4 again is 1. The class width is equal to the 1. So in order to find the class midpoints again, so we need to look to every class. So we need to add the lower class limit to the upper class limit and divide them to the 2, and it's going to give us the class midpoints. Well, the first one is going to be 0.495, I think. For the second one is going to be 1.495. For the third one is going to be 2.495. So those numbers are basically the average between the lower class limit and upper class limit of the particular class. So in order to find the class boundaries, again, so we need to choose the two classes and find the numbers between them. So the class boundary between the first class and the second class is going to be 0.995. Between second and third is going to be 1.995. Between third and fourth is going to be 2.995. Between fifths and fourth and fifths is going to be 3.995, and so on. So everything is straightforward. We just need to know about those concepts. So now let's try to construct the frequency table. So let's create a frequency table. I've got the grades of 40 students. So here there is a list of the grades. So I think the maximum grade is 60. So the minimum, so it should start from the 1. And I would like to create the frequency table. So first of all, I would like to create the classes. So I think so the 15 points are good enough to differentiate the students in terms of the knowledge. So I want to create a table where the class width is going to be equal to the 15. So what I can do is I can create the first class is going to be between 1 and 15. Okay. So the second class boundaries are going to be so I need to add the 15 to the lower class limit of the first class. It's going to be 16, right? So 16 and 30. So if I add 15 to the 16, it's going to be 31, 31 and 45. And the last class is going to be 46 and 60. So in this case, the class width is equal to the 15, right? If you choose any two classes, so the difference between the two consecutive lower class limits is equal to the 15. So now we need to just go through the data points and count, hey, how many data points belongs to the first class between 1 and 15. So let's count this. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10 students have got the grades between 1 and 15. So now I would like to count, hey, how many students are going to have the grade between 16 and 30. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. So sorry, it appears we forgot 12 here. So it should be 11. So now we need to count the number of the grades, which are between 31 and 45. It's going to be 1, 2, 3, 4, 5, 6, 7, 7. And here we forgot 25, it appears. I should go to the 13. So the rest should be the points between 46 and 60. So this should be 20, 31, 9, right? So this is the frequency table for this class. So the frequency table is much more nicer, so we can interpret the data points, and we can say lots of conclusions by just looking to the frequency table, which is much more compact than the original table. So the problem is, so let's say I've got the two tables, so for two groups of the students. One group contains the 80 students, and I've got their grades. So here is the distribution of the grades. Basically, it means that there are 10 students who've got their grades between 1 and 11. So 25 students have got their grades between 11 and 20. 25 students have got their grades between 21 and 30, and so on. So at the same time, I've got another group of students which contains 240 students. And I've got the frequencies there, 55, 75, 60, 30, and 20. Now, let's assume that I would like to compare this to the performance of these two groups. And it's really difficult. So even though I see the distribution of the grades for the first group and for the second group separately. So if I would like to compare the performance of these two groups, comparing these two frequency tables is really difficult for me because of those numbers, because of the different scales of the numbers, right? Because the number of the students on the second class is 240. So the number of these students on the first class is equal to the 80. And obviously, so those numbers here are going to be in the different scale for the second table, right? So is there a way to create, so to compare these two tables in a uniform way? So yes, it appears we need to create the so-called relative frequency table. So instead of just writing down the numbers, so the frequencies, hey, how many students have got the grades between this or that interval, I would like to write this in terms of the percentages. So I've got 10 students between 1 and 10. So what I would like to do is I would like to divide the 10 to the total frequencies, to the 80, and it's going to give me 12.5%. So it means that for the first class, 12.5% of the students have got the grades between 1 and 10. And consecutively, so the 25 divided to the 80 is going to be 31%. 31.25%, it means that 31.25% of the students have got their grades between 11 and 20, and so on. So I can do the same thing for the second table. So basically, I would like to divide like 55 to the 240. It's going to give me 22%. 75 to the 240, it's going to give me 31.25%, and so on. And now, so by just looking to this relative frequency table for the second group and relative frequency table for the first group, we can compare the performance of these two groups. So Okay, so this is called the relative frequency table. We need the relative frequency tables in order to compare the two data sets with a different number of the data points. And in order to create the relative frequency tables, we need to divide every frequency to the total frequency.